Hello everyone, hope you all are doing well. So in this video we'll discuss the last problem of Leetcode Weekly contest 326. It's a medium level problem. Easier than the other level 4 problems that you get. Generally you get the hard level problems at the fourth position, but yeah, this one is a medium one and I also feel the same. It's relatively on the easier side. So the problem name is closest prime numbers in range. So the problem statement says that given two positive integers left and right, find the two integers num1 and num2 such that these two lie between left and right, and obviously num2 is greater than num1. Also num1 and num2 are both prime numbers. Okay, and nums2 minus num1 is the minimum amongst all other pairs satisfying the above conditions. Okay, so return the positive integer array answer where it contains nums1 and nums2. If there are multiple pairs satisfying these conditions, return the one with minimum nums1 value, or return -1 if such numbers do not exist. Okay, a number greater than 1 is called a prime if it is only divisible by 1 and itself. So like for example, left is this, right is this. Okay, so what are the prime numbers between these two numbers? So obviously 11, 13, 17 and 19. So you have to include left and right as well, so that is why I've included 19. Now find the pairwise difference. So this is 2, this is 4, this is 2. Okay, so you can see the minimum difference is 2, but this is for this pair and this pair. So you pick this pair because in case there is a tie, you pick the pair with minimum first value. So here the first value is 11, however here the first value is 17, so you pick this pair. So you can see 11, 13 is your answer. For the second case you have 4 and 6. So what are the prime numbers? Only 5 is there, so we need to choose two distinct numbers, right? However there is only one prime in this range, so -1 will be your answer. Okay, so it's an implementation based problem, nothing fancy is needed. Okay, we can directly jump into the code. I don't have any extra thing to explain here. This is my main function. I call a function sieve of Eratosthenes right now. This is the core logic, why this function works. So this is the function that is written. So sieve algorithm is used to find the prime numbers up to an upper limit, you can say, right? So here this n basically tells me that what is the upper bound till which you want to find the prime numbers. Okay, so this is something I pass right. Okay, now what is sieve algorithm? That is a totally different topic, but let me just give you a feel of what is that algorithm. Okay, so what happens, suppose you have a boolean array from let's assume 1 2 3 4 5 dot till suppose 100. So now what you do, this is obviously not a prime number. Okay, so you come to the first number, this one. Okay, what you do, so 2, this is the first number, so this was still not visited. Okay, so what you do, you pick this number and you visit all the multiples of this number. So it will be 4 6 8 till 100. Okay, so all these are visited. Now you move to the next number which is not visited. Okay, you move to 3. So what you do, you again cut all the multiples of 3. So it will be, so 3 is the first number, you cut 6, you cut 9, you cut 12 and so on. You keep on doing this. Now you come to the next number, but you just see 4 is already visited because of 2. Okay, 4 is already visited, so you move to the next number, that is 5. So actually what is happening, the prime numbers are not visited. You visit the prime numbers only one time. However, for the other numbers, you have visited them when you visited a prime number, okay, whose multiple was this number, right? Because a prime number has factors 1 and itself, right? 1 and x. However, other numbers, so any number will be a multiple of a prime number, right? You pick any number because any number can be represented something like suppose p1. So p1 power x into p2 power y and so on, right? So these prime numbers. So this is the main concept of sieve of Eratosthenes. So you can see here what I've done. Initially we say that till n everything is prime. Okay, now you start from 2 and you do p into p is less than 1, so less than n. So this is an optimization. Why you do that? Because actually what happens now, suppose you are at number 36. Okay, you are at number 36. So this has multiple factors. Okay, so when you start cutting the numbers of when you start cutting the multiples of 2, so you cut 4, you cut 6, you cut 8 and so on, right? Similarly, when you come to 3, so you cut 6, you cut 9, and so on. So what happens is all the numbers which are less than this value p square, okay, have already been cut, so that is why you add this optimization. Okay, now what you do, if prime of p equals true, that means it has not been visited. So what you do, you start from p square until n. See another optimization, you jump at every step, you jump p, right? Because currently p is your number, p is your prime number that you have visited, and you are cutting all its multiples, so you jump p steps at a time. Okay, certain optimizations are done, and you mark them as false. Now when this loop is over, so all the prime numbers are true, and the other numbers are false. So what do you do? From 2 to n, if the prime of I is true, then you add it into your list. This is my list that I have created. So primes dot add of I, right? So here what we are doing is we are creating a list. Just a second. Yeah, we are creating a list of numbers which are from 1 to n. Okay, simple stuff. So this is what we are doing here. This is what this function is doing, and it is adding it into a list. Okay, so once you have done this, so just see, you have called this function, this is your answer array. Now you do basic stuff. You initialize your min diff with obviously max value. These are the two values, right? So this is the first loop. What I have done here, again, you could have done it in a single loop as well, but I was writing code in the contest, so I was trying to do it pretty fast, so that's why I did this. So you find the first number which lies between left and right. Okay, you break the loop. Now what do you do? Simple, traverse the numbers in your prime list which are within this range. So right is obviously tackled because you generated the numbers till right only. Now left is also tackled because of this loop. So what you do, j equals to I plus 1. Here we got the value of I, the first value which was greater than or equal to left, right? This is the equation. So you find the current diff, that is the jth number and j minus 1th number. If the current diff is less than min diff, you update your min diff, you update your numbers, right? How do you tackle the case of duplicate? So in case you get a diff which is already equal to min diff, so you don't update v1 and v2, hence you get that case is tackled. Okay, finally you come out of this loop and you update your answer of 0, answer of 1, and then finally you return it, right? So yeah, that's it for this problem, relatively on the easier side, but I hope you learned something new from this video. So do support it by giving up a thumbs up, do subscribe to the channel as well. In case of any queries, mention that into the comments, I'll revert on each one of them. Thank you, take care, bye.